please join me in welcoming Marcus to the stage.
So we've done a lot of thinking. You know, one of the nice parts of being in Bell Labs is you get to think broadly and be surrounded by smart people. So I wanted to start with this thinking. So if you look at our industry, that's the ICT industry over the last 30 years, you can see the following. And it's both the I companies, the C companies, and generally the whole space. So this is some I companies, HP and IBM. This is their market capitalization over time. And you see that basically for 30 years, other than two financial perturbations, the first financial crisis, the second, and then the mortgage crisis that comes on the end of that, nothing really changes. You start and finish in the same place. You just bump along with the financial market. It's remarkable, isn't it? Here's us in all versions of Nokia, and then AT&T. And it looks like AT&T is going in a good direction, but that's all by acquisition. That's DirecTV and Time Warner. So in fact, that really hasn't changed. They just agglomerated other companies, so relatively flat in that space. And if you look more generally, M&A in our sector, it's roughly flat. And with startups forming in our sector, roughly flat. And all that happens is the financial markets sort of bump us along. You could argue it looks like waves of success. That's the title. But I would argue we're just being carried along by a financial current. So that's a bit depressing, particularly when you look at these companies. Here's Amazon. You see the bumps are there. They're almost invisible if you go over here. Two tiny little things. That's the bumps, the impact of the financial crises on Amazon. Here's Apple. The bumps are also there. So you say, okay, well, those are device players, web-scale players. They're in a different segment. They ride over the top or they ride underneath of you. But then here's one that's more interesting. It's Microsoft. And if you look at where it was going, the bumps are much more visible. And then up till 5 years ago, it was asymptotically going back to where it started, just like all the companies on the top line. And then suddenly it goes in a different direction. And how did they do that? They didn't do that with their new product. They don't have any new products, really. They may have a new offering with Azure, but the product is still their Office suite. Office suite, they decided finally to map it to the cloud or deliver it in the cloud, make it available on any device, and then have a cloud offering as a service as well, which is the Azure offering. But that's all they did. They took their existing asset, repurposed it, repackaged it for the modern era, and have preeminent value. Now one of the world's most valuable companies, give or take a month. So why do I bring that up? I think that's what's going to happen to our industry if we understand the transition it's about to undergo from sort of wide area consumer-centric to a bit more focus, in fact, quite a bit more focus on industrial and enterprise. Doesn't mean to say the wide area networking focus isn't important, because the only way to make LANs work in a global context is to use a WAN. So LAN-WAN interworking will be critical, but this shift towards enterprise industrial focus is the thing that has the potential to drive us along that Microsoft-like curve as an industry. They're using wide area networking to interwork those local area networks. So I want you to keep that in mind as we go, because all of that is about productivity. You could argue the Office products are about productivity. You may say that they actually now have got to the point where they reduce our productivity because we just produce slides rather than real thinking. Yes, so somebody who laugh, and Word may in fact make it too easy to type random pieces of data and documents rather than really think things through as you did when you typed. But nonetheless, they are designed as Office productivity tools. So I'm going to come back to this productivity theme. Okay. Here's the problem. Until recently, and right up until now, productivity has been undergoing some phase changes. So this is the first and second industrial revolution. I've showed you this before from Robert Gordon's book, The Rise and Fall of American Growth. I note the title of the book is The Rise and Fall. He is not optimistic that there is a new dawn. But this is the first and second industrial revolution. Productivity goes up. This is productivity growth, so every few years it's going up. So that looks good. That's when we built physical networks based on physical systems, physical machines, physical transportation, vehicles, physical infrastructure, roads, rail, etc. And everything was going well. And then here's the internet age. This is what we have built. The digital age has resulted in declining productivity growth. And my argument is because of that. That cat is to blame. Well, not that specific cat. Cats in general are to blame. In fact, not even cats. It's our watching of trivial, purposeless cat videos. And you see, you're all watching that. You're not looking at me. You can't help yourselves. You should be ashamed. But there's a serious point here. We create digital infrastructure that we have used for consumer purposes, the consumer internet, if you want to call it that. And what do consumers do? They entertain themselves. We, as consumers, entertain ourselves with trivial things. That's what we do as humans, unfortunately. And then when we're not doing that, watching cat videos, this is the data on what we're doing. Number one, this is growth in mobile app sessions over the last year or so. Shopping. Number one is shopping. Number two is cat videos, if you can't read that. Number three is business and finance. It's true. We now engage in a little bit more facile commercial transactions, whether it's banking, trading stock, etc. And then everything else is declining. Makes sense, of course, because there's only one. Well, actually, there's two business models for the internet. You pay for the on-ramp, and the mobile on-ramp in particular, which is why you pay service providers a monthly fee. The other model of the internet is what? Advertising. Right? Advertising requires you to buy stuff for that model to be sustainable. So, of course, you're driven to buy. And you can even argue that the cat videos are now have embedded advertising all around and even embedded in them. So, in fact, the first two are basically advertising-driven models. Shopping and entertainment are all around driving an advertising model. So we've created exactly what you would expect based on the business logic of the current internet. And it's not particularly value-add. Well, maybe I should ask you, do you think that the future internet, 50 years from now, we will have a plot like this that says we have shopped more? So who votes for the future of the internet should be more shopping and more cat videos? Dog videos? No, it's not. So then there's something else coming, and I want to talk about something else coming. So here's another way to look at that last 30-year period. This is looking at the value stacks in the ICT industry. The first two are I's, supercomputing and then personal computing. Then comes a C era of mobile phones. And you could say that the smartphone era is a C era, but I'm going to argue it's the first ICT era where information and communications technology came together. But the most interesting part of this, and I'll go through it briefly, is that every 10 years something changes and the value stack changes. The way to read it is the highlighted blue were the most valuable things and the grayish ones are devalued. But look at the stacks. They change every so often. In fact, they change every decade. And that's the shift in value of companies. So it's a very important thing to contemplate because each decade, someone wins and someone loses. So let's go through it a bit. Supercomputing era, the first one, the I era in the 1980s. What mattered was mainframes that were large and complex. So it was expensive hardware, important hardware, difficult to build. It needed an OS that would manage that distributed, complex piece of hardware, and that was the Unix era. So you see those are the two valued things. It wasn't really a human-machine interface of note. That's HMI's human-machine interface. In fact, it was mainly punch card. So I have to ask, just for fun, how many of you have ever used a punch card? Yeah, you're with me. Yeah, exactly. That's why the mustache again. So yeah, I used punch cards when I first started computer science. That isn't really the most preeminent human-machine interface. There weren't any apps. You just coded in Fortran, COBOL, Algol, etc. There was no real network. It was just cables into the supercomputer, and there was the early internet called the ARPANET. So everything shifts then from that era to, driven by Moore's law, we create small supercomputers, which we put where? Where do we first put those small supercomputers? Where do they go? Do they go home or do they go to your desk? They go to your desk. That was an enterprise-driven transition. It was clearly that supercomputing was an enterprise paradigm, but now we create small versions of those and we put them on our desk to do what task? What were the first applications? Yeah, Lotus Notes, accounting, WordPerfect. They were Office applications. It was sort of the Microsoft Suite era. So we had two first eras. The two I eras were enterprise-driven. First of all, mainframe computing, so you could compute more, you could calculate more than the Office transition if you want to, so you could be more productive at your desk. And then, of course, you took them home, and that was the end of your life as you know it because you could never get away from work. It's the unintended consequence. So now let's pause on I's and go to C. This is the era of Nokia, the smartphone, feature phone as we now call them, era, and look at that value stack. That was the only transition I would say we've made in our industry before, meaning our native industry is comms. Yes, we build networks, but our native sort of value paradigm is communications over those networks for our embedded industry. And that is the only transition I would say we've made natively in our industry, which is to go from fixed to wireless. All the other things were infrastructures that were enabling a transition from fixed to wireless communications. Different value stack. Hardware is hard to build because it's small, has to be long battery life, et cetera, has to be robust to being dropped. There weren't any apps. There was just voice, text, and Snake. So you really need a bootloader. You don't have an OS. There was a network. For the first time, it became clear the value of a network because you had this high-performance mobile network that was unprecedented, and then telecom apps. This is the first bubble era. So that's that one. So what happens? What happens is Apple realizes that, in fact, the C and the I should come together. I would say Apple has always had bad phones from a comms perspective. They've never had the best voice interface. But they've had the best mobile computer. And of course, it's logical. They had the Newton that came first, even before the iPod, and then they realized that because of the success of 3G phone technology, they could embed that in a computing device, a tablet, which they then reduced down to the size of a phone and created the smartphone. So I would argue what Jobs really saw, other than nice touch interfaces and building an ecosystem that drove the adoption of that, is that this was the mobile computing era, and that's what he created. The problem with that era, for a Nokia standpoint, was in the mobile computing era, OSs matter like they matter on computers, and the one thing Nokia didn't have was a uniform OS. They had many OSs working on many phones, and each app had to be redeveloped for each of those OSs. So in fact, the R&D was spread across many different platforms. Apple, of course, created one unified system based on their heritage in PCs, in Macs, and rode out that transition and were very successful. I'm now going to, by the way, I do have my favorite quote. This is Risto, our chairman, wrote a book. He points out that at the end of Nokia realizing they didn't have an OS, they went to Google and offered to be the default platform for Android. So in other words, we've got phones, you've got Android, let's get some market advantage by working together. And Google said no. And they said, why? We asked why, and they said, because you're dead, you just don't know it yet. If you think about that, they understood the transition that Steve Jobs understood, which is that the OS was going to matter and was going to be king. The device was just going to be a platform that the OS ran on, and then ecosystem mattered. In Google's ecosystem, of course, it was search and related applications. But that's important. They saw it coming. I'm going to argue that the reason I'm talking to you today is we see something coming. And each time you see these things coming, it's not obvious to the incumbent that that thing is coming. Because, in fact, it looks so good to be in the current space, you can't make the transition. So here's what is going to be the future. So these are the waves. You see the nice waves. We had that wave theme. The future is going to be different. In the 2020s, it's going to be about much more natively augmented devices, physiological, physical, mental. And I'm not going to talk about what those devices are. I have a particular view, but they're going to be much more intuitive, and they don't get in your way like this. But the other property they're going to have is, so that's why the human-machine interface becomes critical, is that they won't be complex. They will be everywhere. They will be embedded in your clothing and earbuds and whatever. They won't really have an OS because they won't run any apps. The apps will be in the cloud and take the form of augmented intelligent assistants, one or more of them, which is why I put Guy up there. But for that to work, those assistants have to be personalized and run close to you because you have to be in low latency contact with those assistants because you're running your life through these things. And for that to work, you need a high-performance network. So you understand the argument. I'm going to get rid of apps. You don't use the apps on your phone anyway. You know you don't. You use 5. And the reason is because you can't actually make use of those things. They're all contextually different. They don't share common knowledge. So we're going to replace that with some set of augmented intelligent assistants to just tell you the answer. You want to book something, it books something for you. You want to ask Wikipedia a question, it just asks the question for you and answers. That runs in the edge cloud to get the high performance, low latency, high reliability, and that requires a high performance network. That works for you as a consumer, but it really works for enterprises and industrials who essentially employ people and robotics that need contextual information delivered in real time with low latency, high reliability to perform tasks. That's what productivity is about. So the essence of this future is this. I like to think of as proximity networks, and I'll explain that. That is about the concept of the cloud moving closer, but also the radio layer moving closer, and in fact, both of those moving inside the enterprise to create private networks. It is new productivity tools, that's the augmented intelligence systems, and in the end, personalized knowledge. So those are going to be the three things, okay? How do you do that? Now I get to my point. 10 minutes in, I finally make a point. End-to-end solutions. So you can't actually deliver any one of those things without coupling it to the other, and I'll explain that in order to get, again, very high performance, call it mission critical, call it life critical. If my offer to you is the service I'm going to offer you, because I built it incoherently a little bit, and different software upgrades and different hardware platforms come at different points in time, I'm going to offer you to a service where 97 or 98% of the time it works, but 2% of the time it doesn't. How do you like that service running your life? You don't like it at all. So we're actually going to have to integrate these things in order to make it all work. So I'm going to talk about how we're doing that. Okay? Good so far? You with me? End-to-end solutions is king. So I wanted to build on knowledge. This is just interesting. You can consider it an aside, but it's a pretty interesting one. So there's a curve. There's a guy called Buckminster Fuller. He was a very smart guy. He did the geodesic dome, etc. Had a theorem he developed in the 1980s, I think, that said that knowledge doubles every period of time, and in each successive period of time, the amount of time it takes to double it is half. So it's sort of a double and a halving. A bit Moore's law-like, but actually it's got two effects. It doubles and in half the time, whereas Moore's law doubles in the same period of time. So this is a very aggressive power law, and basically it goes like this. He said by 1900, knowledge was doubling about every century. And then after 1900, it's been 50 years, 25, 12, etc. And now we're at the point, and this was an IBM piece of data, that knowledge will double in the post-industrial IoT era every 12 hours. Which sounds frightening. It's even more frightening because think that knowledge will be required to be consumed by you in some fashion in order for you to be current. But here's how you behave. This is called the Ebbinghaus forgetting curve. It's a psychology experiment that says you forget everything within a day unless you refresh your memory. In most cases, after 15 days, you're hopeless. In fact, you're more dangerous than you are useful because you think you know. And it's the worst thing you can do. Don't even think you know, because then you'll ask someone who does know. But this curve says you think you know for a period of time, so you make really bad decisions. So that's humanity. Knowledge going up, forgetting staying where it is, so we've got to do something about that. And that what we're going to do is create this paradigm, right, of intelligent assistants that help us to be better at understanding what is contextually relevant for us to do tasks. Those tasks will be either enterprise, industrial, or personal, but for that to work, we need high-performance networks. Okay? So here's today's network infrastructure. It's relatively static and centralized. So you've got centralized cloud running connectivity services, web applications, analytics, AI, and even security is all centralized. Then you've got nice IP and optical transport running to central offices and switching centers. Anyhaul, which actually today we should just call backhaul. It's moving to become anyhaul, but backhaul access network that's relatively centralized, meaning macro-centric in wireless, increasingly long fiber runs in fixed, and then enterprise and consumers are treated roughly the same. It's all around best effort consumer internet that is sold to enterprises as either a mobile service in SIMs or a VPN that generally runs over maybe some MPLS infrastructure in the core, but still probably is still a best effort service where it's got a peak rate, but it doesn't have a committed information rate. Okay? So watch this. Subo on my team is a clever animator. This is the shift. Okay, that's the new network of the future. So centralized cloud, notice everything sort of migrated from the centralized cloud and appeared in the edge cloud. All the things that migrate is anything you care about because it's mission critical. So that is analytics, that's the brain symbol. It is data storage of local contextual relevance and knowledge. It is security services because you have to secure everything at the edge. And the application itself. Because if I need low latency, high reliability, the whole application and service has to be rendered within that interval, and that interval, as I've said to you before, is within 100 kilometers of the end user. And that's just to do with the speed of light. If I need 1 millisecond of latency, I have to be 100 kilometers away from the endpoint, because that's the distance light can travel there and back in 1 millisecond. So 100 kilometers. Suddenly, everything shifts from web cloud to edge cloud. Doesn't mean to say you won't burst into centralized cloud. Of course, you will for non-real-time, not mission-critical services infrastructure. Then backhaul becomes anyhaul. The macros shift to becoming much more intelligent, the beamforming macros, 5G macros, so I can actually do more interesting things in terms of signal to noise. I can get 5 or 10-fold advantage of signal to noise. Then I put this underlay of millimeter wave small cells. Why will it be different from small cells today? Because it's non-interfering with the macro. It's all millimeter wave spectrum, beautiful millimeter wave spectrum, has nothing to do with what's going on in the macro, so I can just add those. I don't have to worry about interference between them. And of course, if you look, I separated enterprise and consumers, because look what happened in the enterprise. A private infrastructure got built in the enterprise. There's a cluster there of a prem cloud, also with applications, analytics, security, and a private network running there with, I show millimeter wave small cells in the enterprise. Big shift. Now, don't forget the bit on top. The bit on top, network orchestration and automation, end-to-end, each domain, and service orchestration and automation. That wasn't there in the previous diagram. There was a manual provisioning system that I didn't even bother showing because it didn't do anything interesting. It just made the base foundation work, and it sat that way forever. It wasn't a dynamic system. Now we've got dynamic network and service orchestration and automation, end-to-end. So now you start understanding the end-to-end story. You could build all these pieces separately, but you will not be able to orchestrate them and automate them. I could orchestrate, but I can't automate that if I have no control of the individual pieces. Even if I had control when I first deployed it, every software, firmware, hardware upgrade, you would need to re-automate. Think of an AI system that you'd have to retrain for the configuration that you have now deployed, and you ideally would like to deploy new configurations every month if you had sort of cloud native or web scale type attributes, right? You'd actually want to redeploy or deploy new features, new capabilities every month. So you can only do that if you pre-integrated the solution. Someone is taking responsibility for that. So the argument for end-to-end is going to be, yes, lower total cost of ownership, but it's the only way you can deliver automated, scalable, adaptive services. So that's what this looks like. We've got a nice little animation. I've got these devices running, consumer and enterprise, and they essentially dynamically create and manage network slices. The attributes of these network slices I want to talk a little bit about, because or this infrastructure has 5 sort of main needs, and they're going to turn into the 5 end-to-end solutions I'm going to talk about. So the critical connectivity, think of that as the end-to-end 5G base layer. You see that one? It's about capacity and lower latency. To the left of that is local area networks, or private networks that Rajiv talked about. That's the same thing done locally and privately for enterprises. Behind that is dynamic distribution of cloud and related network functions. Then we need to secure everything. So we need to actually run on that distributed cloud infrastructure, highly secure, analytical, device management, IoT services. And then I need to scalably slice that whole thing end to end, LAN to WAN, all the way down through the security layer, the cloud layer, so that the sort of end-to-end piece of security manifests there. So we've come up, this is how we've come up with the 5 end-to-end solutions, which I want to talk to you about in the last few minutes. So I want to build on Rajiv's point that end-to-end is already happening, and then I'll tell you what the end-to-end solutions are that we're focusing on. This is already multi-BG deals that we win. It's about 50% of our pipeline, and look at them. They're done by the number of domains. So a domain is a future X domain, roughly. So access, transport, backhaul, cloud, etc. So 2 domain wins, we have 23, 3, 28, 4 domain wins, 54 by far the largest number, but even 5 domain wins, 5 Nokia domains sold in one deal or sequentially into the same customer, 38. It is 50% of our pipeline. That couldn't be more real to us. Now I want to explain how these get sold today, because Rajiv gave you a pretty good overview, but I'll make it even more clear because we're changing this a bit and it's evolving. So here's how they get sold today. They get sold a little bit as blueprint architectural solutions. So the world starts as you just bundle things together and say, we'll give you a better price. But then we evolved that to something that had more integration, But it was a low level of integration reality. We actually integrated it once, and we didn't continuously upgrade that evolution. So it had lower OpEx because it was slightly more integrated. We've now moving towards these multi-domain integrated packages where we actually integrate and test the solution and then verify with each new release that that new testable thing still meets the performance criteria or in fact has higher performance criteria. So that's what we're moving to now. The interesting part of that, and I'll show you how this works, you can buy those smaller packages, which you think of one would be access, another would be IP and optical, another would be converged core. You can buy them sequentially, and because they've got a common network and service orchestrator that they all plug into, by the end you've accidentally built an end-to-end solution. So you don't have to go and say, I'm going to rip out everything and replace it with a new end-to-end solution infrastructure. You just start buying coherently packages that, rather like Lego blocks or jigsaw puzzle pieces, fit into the larger puzzle with the common orchestrator. And that's how you get to end-to-end solutions. Okay, so now I'm going to show you what they are. It won't surprise you that they look like this, and I'll explain the whole thing. So here are 4 of them. I mentioned base layers end-to-end 5G. Underneath that, if you think foundational end-to-end distributed cloud, above it, network slicing, and then above that, security, because in fact, you have to manage the security of each slice, so think of it that way. And over at the side, end-to-end industrial automation.